we'll be looking at thermal cracking and then precisely steam cracking. The source of heat is from steam, okay? Steam cracking. And the major reactions that occur, we have initiation. Initiation is one. So let's take a look at the thermal cracking of ethane. Ethane, right? So the initiation under steam cracking has to do with the breakage of the carbon to carbon bonds. Alright? These bonds break like that to form radicals. So we have two methyl radicals being formed. Alright? So the second stage or the process that occurs after initiation is called hydrogen abstraction, where the methyl reacts with the same components in the reaction system to produce some other product. And this is how it occurs. You can take one of the methyl radical here. So we have methyl radical, all right, reacting with this. So essentially we have CH3, right? I just want to show hydrogen abstraction. This is CH3, okay? So what basically happens is the methyl abstracts the hydrogen, all right? How that happens is that this is one electron, like that. This is this label bond here, okay? Then half of this onto the carbon. So essentially what we're going to have is there's going to be a bond. You can see hydrogen is taking, the methyl is taking up this hydrogen, all right, to form a bond with it. So we're going to have methane being formed plus the radical, the CH2 radical. So we have CH2 radical here. Then with the CH3, as you can see. So this is what the hydrogen abstraction produces, okay? First, if you could observe, we had the initiation, the hydrogen abstraction, which gave us this, all right? Sorry, it's not supposed to be so. So which gave us this. So the next stage is called radical decomposition. Ethyl radical has been produced, right? This is an ethyl radical. So radical decomposition occurs. This is the radical that will decompose. How does it decompose? It's actually going to yield an olefin, olefin at double bond. So we have CH2, right? This is CH2 with the radical. Then we have CH3. So what essentially happens is that this electron here, the carbon-hydrogen bond is broken like this, homolytically. So it means that we're going to have a double bond here while the hydride is being formed. So the product is going to be H2C, double bond CH2, CH2. This is off with anhydride. So hydrogen radical here. Can you see that? So we have initiation, hydrogen abstraction. This is hydrogen abstraction, okay? Then this is radical decomposition to yield the olefin. Essentially, this is how the olefins are being produced by radical decomposition in thermal cracking. Precisely, this is steam cracking, okay? So the next stage is radical addition. Radical addition, in the sense that the ethyl radical that has been produced, we had an ethyl radical, right? Where is it? The ethyl radical that was produced let me put it this way. Okay, gets to react with the olefin. We generated an olefin, which is 18. Alright, this is how it is being added. So what is going to happen is this bond, you can see this, how it breaks again. Alright, and it breaks again. So we have two of that. So we're going to have this reacting with CH2 this way. I'm just trying to show it stepwise. I don't want to skip the steps. So what happens is that these two bonds, right? So when these two bonds, we're going to have the propagation of those two. So we have CH3, CH3, we have CH2, CH2, then we have this bond to this carbon, which is this, then we have CH2, then we have CH2 again, which is a radical. So you could see here we produce a butyl radical. So based on the product you are looking for, we can continue doing this over and over again. This can choose to react with this can choose to react with this, over and over again till it terminates. So the last stage is called the termination. Termination stage, where the free radicals gets to react. Okay, let me wipe this off. The radicals can choose to terminate either by disproportionation or by recombination. So by disproportionation termination, let's say for example the ethyl radical is trying to terminate. So we have, let's say, CH3. I'm trying to give an example of disproportionation. So let's say these are ethyl radical, we don't know, and it's trying to terminate. Let's say we have another ethyl radical. Alright, let me put it this way, just for ease. Alright, what it means is that one of the radicals tends to take up the hydrogen. There is a hydrogen transfer to the other radical in the center. This one, okay, same thing that happens. See how it breaks. Okay, so we have, essentially we're going to have this being produced, CH3, then CH3. This is an ethane. It's no longer a radical, it has terminated. So here we then have, what we will have here is this. We're going to have CH, H. There's a radical here. Then with the other H. The other H has been taken up here. So we're going to have this, which can then recombine like this to give you an ethene. So essentially we have H2C double bond CH2. See, the ethyl radical can choose to terminate, forming an ethane and an ethene. The reaction goes to halt. That is disproportionation. Okay, then we have the recombination. So for the recombination, we can choose any of the radicals that we produce. We can have the methyl radical, okay, reacting with the hydride to give you methane, which we know, alright, or we can choose to use this methyl radical reacting with the ethyl radical, alright, it will just recombine. We have this CH3, CH2, CH3. So these are just few examples, okay? On and on, you check all the radicals that were produced in the system, and then you terminate them based on either of these two steps. All right, this is all about steam cracking, which is thermal cracking.